Hello, friends. Welcome to my spaceship. I'm actually beaming right into your social media from my command center. And in this live stream, every day I come in front of you and inform you, discuss with you about some of the latest happening in the space time in the nearby vicinity. So, as we are living on Earth, and we have something very interesting to find out, which will give us more information about how our galaxy function and what we can expect when we examine the galaxy up close. And therefore, let us begin our discussion today. And as we know that the Milky Way is a very large place. It's one of the large galaxy. It is not as large as the probably the largest galaxies that we have seen so far, but it is pretty large place. From one end to the other end, now as per the latest study, with all the features which are present in the Milky Way, the Fermi bubbles and the ripples that the Milky Way has, it is estimated that it is about 180,000 light years across, or maybe more. So this is as per the current understanding. And the biggest mystery of last 150 years is that the motion of the galaxy is very difficult to explain. And typically the stars which are on the exterior side or the far out from the center must move slowly, must move slower than the stars which are in the middle. And that is the logical explanation, pretty much like comparing the motion of the planet around the sun, when the outer planets move slowly, whereas the inner planets move fast. The fastest moving planet is Mercury, which finishes its entire rotation around the sun in just 88 days. So similarly, it was expected, using the logical mind of the scientists, that the stars which are on the outside, on the outskirts, would be moving rather slowly, but that is not the case. In fact, the stars which are in the outer region of the galaxy are moving rather fast, and they are moving probably as fast as the stars which are present in the center of the Milky Way. So the motion of the Milky Way is pretty much constant across the disk of the galaxy, which is very difficult to understand. This is something which is a mystery, and because we do not have answers to this mystery, and based on our calculations, it is estimated that in order to hold these stars in the grip of the galaxy, you need to either slow them down, which as per our observation is not. They are actually moving rather fast, and in order to hold them in the orbit, proper orbit and proper position around the galaxy, you need to have extra mass. So when we look around in the galaxy, we don't see extra mass to create extra gravity, and it turns out, based on these equations, that we may need 5 to 6 times extra matter in the galaxy in order to hold these stars together. Otherwise, the galaxy will just rip apart and the stars will fly away at that speed, at breakneck speed at which they are going. So, because we do not see this extra matter anywhere based on our observation, so we actually say that the galaxy is bound by something called dark matter. And then we have also given very exotic property to this dark matter. Some of these properties are that the dark matter is something which is non-reactive. It does not have any charge. It does not react with itself. It does not even interact with the matter, and it can pass through the planets and stars without any interference, and it's omnipresent. But it has all these exotic features, but it creates gravity. So a dark matter which we cannot see, we cannot observe, yet it is present all around us, even within our bodies, present everywhere, for the sake of creating gravity. Now the latest discovery that we have got is that maybe the dark matter may not be the real deal. Although we see a lot of dark matter in the halos of galaxy, indirectly, because so far we have not been able to find even a single particle that explains the existence of the dark matter. But let's shift gear for a moment and let's talk about what are the other candidates that could have been there to create extra gravity. And now let's talk about the stars. So we have all kinds of stars in our universe, in our galaxy. Some are very large and some are small, some are mid-size. So sun is a mid-sized star, but eventually whatever type of star you are, because galaxies is full of stars. So whatever type of star you are, or whatever type of star there is, it will have to die one day. It will consume all its fuel one day and then collapse under its own weight. And because the stars are pretty large. Well, if you look at the our own solar system, we have so many different planets, large planets like Jupiter and Saturn. Yet the central star, which is Sun, has 99.8% of the entire mass of the solar system inside that body, single body. So the rest of the matter in the solar system is only so little. The highest amount of matter of the entire weight of the solar system lies in the central star. So stars are pretty big. And since they are very big, they have a lot of gravity. They create a lot of gravity. They also influence, based on the gravity, even the far off bodies. And there is a huge circle of influence every star creates. Even though the stars are small, they will still have this kind of feature. They will create gravity, they will create energy, they will create heat, and so on and so forth. So even if you're a very large star, there is a very large star, it will collapse faster because it will consume the fuel faster and become a dead star. So when we talk about this star dying, taking birth, of course it is giving light and it is burning because of the fusion reaction. But when the star is dying, what does it mean? So if there is a star which is like our sun, eventually in 10 billion years, this sun type star will run out of their fuel, and once the fuel runs out, the kinetic energy or the heat which is being produced in the core of the star will reduce significantly, and because of that the star is very big, very large, but it does not have so much gravity left now that it will be able to hold the material which is in the exterior part of the star. So all that will become loose from the star and move away in the form of a nebula. So basically this is the end of the life of the sun, and whatever remains is the very heavy core called white dwarf. And white dwarf will basically just cool down. It will take trillions of years to cool down, and eventually scientists say hypothetically it will become a black dwarf. That means it is completely cooled down and it will be a ball of carbon or diamond. So this is the white dwarf, but in order to become a carbon or diamond, it will take trillions of years of existence as a white dwarf. And this is the size of probably a couple of times the size of Jupiter. So this is the first category that white dwarf will form as a stellar dead body. What are the other options? Well, other options are more exotic, and these are usually related to stars which are much bigger than sun. So if the stars are much bigger than sun, then there are two possibilities. One is that when the star starts to collapse after the fuel runs out, then this collapse is very, very quick, because the star has a lot of extreme properties. It is very big, it is creating a lot of pressure inwards, and since it is creating a lot of inward pressure, it is also creating more kinetic energy in terms of more fusion being created because of this pressure, and therefore the pressure is very intense. And then suddenly when the fuel runs out, then this pressure takes over in an instant, in less than a second, and then it collapses on its own weight and crushes the whole thing out. And at that point in time, the Newton's third law becomes active, which is for every action there is equal and opposite reaction. So when it starts to crush in an instant, then that instant motion will have a opposite reaction, Newton's third law, and the entire star explodes in a supernova. Now, based on the mass of the star, there are two outcomes of this supernova explosion. One is, if the star is not very large, then it can collapse into something called neutron, because this pressure will keep crunching the core, and eventually it will start affecting the matter atoms in the core, and this pressure will be so large that it starts influencing the strong and weak nuclear force which exist in the atoms, overcome all of them, and electrons will fall into nucleus of the atom, and then everything becomes neutron. So this is one of the stellar dead body that can come, that can basically evolve after this. But if the star is pretty large, like at least 20 times larger than the sun, then even the neutrons will not be able to stop or the pressure, the inward pressure, and then completely collapse into something called black hole. Black hole is a very difficult body to understand, simply because it creates a singularity, and it creates so much gravity. It has so much gravity that even light cannot escape, which is the fastest thing in our universe. So to compare the size of a neutron star, 5 to 10 times the size of sun collapsing into neutron star will be only 10 kilometers across. So it will have the mass of at least 1.5 times to 2 times the mass of sun, but all that is so compact and crushed so much that the entire body, even though it is as heavy as twice the size of sun, but it will fit into a 10 kilometers small ball, and everything is made of neutrons. There are no atoms, everything is neutrons, only 10 kilometers across. And so this is one extreme body that a large star is able to create, and it's considered as a dead star. The second is a black hole, which, if you compare the size, will be half the size of a neutron star. So if there is a 20 times the mass of sun collapsing, it will create a black hole hardly 5 kilometers in diameter. So you can imagine that 20 times larger star collapsing, and black hole size will be only 5 kilometers. So these are very, very small objects, very difficult to see, and especially they don't emit any light. In fact, they have so much gravity, they even absorb any matter which comes near them, including light. So these objects are very difficult to see, and as per the latest study, what scientists are saying, that since galaxy has been operating or in existence for almost 12 billion years, many stars have come and gone and become these stellar dead bodies over the past 12 billion years. The universe itself is 13.7 billion, 13.8 billion years old. But in the life of the galaxy, which is 12 billion years, many stars might have gone this way. It might have become black hole, might have become neutron stars, or might have become white dwarfs. All of these three corpses of stars are very difficult to see, extremely difficult to see. We see them only when they start absorbing some material. Because of this absorption, the X-rays are created, and using our X-ray instruments, we can see that there is some high energetic activity going on, and that's how we see them. So there would be many black holes, there would be many white dwarfs, there would be many neutron stars spread across entire length and breadth of the galaxy. And these are very small objects, as I explained to you, and also very energetic, with very high gravity. So as per the latest analysis of using the statistical model, scientists say that every 100 light years there will be one of these corpses. So every 100 light years, and as I said, the galaxy is a very large place. So from one end to other, it is almost 200,000 light years. So every 100 light years from each other, there is either a black hole or a neutron star. That means we do not know if there is something nearby our solar system. And if there is something nearby, it could be quite dangerous. It could also affect us gravitationally and stuff like that. There's another theory which is being talked about, and this is related to the dark matter, is that since these objects are very heavy and they have been being produced for a very long time, and then they have to wait till the end of the universe for the next, and they survive in this form for trillions of years. That means once you have formed a neutron star or a black hole, you will survive in that state until unless you evaporate. So that evaporation process will take trillions of years, and we are universe is quite young, only 13 billion years. So if evaporation of black hole takes trillions of years, evaporation of neutron star takes many billion years, that means these bodies will survive for a very long time, at least longer than human civilization. So what is going on here? Basically, because of this motion of the galaxy, and they have been in existence for quite some time, all these stellar remnants of past large stars, they gradually start moving out of the galaxy and accumulate in the exterior part of the galaxy. And if some of these bodies may eventually lose the grip of the galaxy and then move away. So this is how, because galaxy is a large place and these bodies are very small, you can imagine that when you boil water, you have this water molecule evaporating. So this is something like that. You can compare this process by understanding as if the galaxy is evaporating by losing these small black holes and neutron stars and sending all these bodies, heavier bodies, outside the galaxy. And since these bodies are so many, what scientists have found that even though we cannot visually see them, it is very difficult to see them, because in case of black hole it is impossible to see them. These bodies move out in the exterior of the galaxy beyond the size of the visible galaxy, and basically create that extra gravity which may answer our motion problem that we started our live stream with. That may explain extra gravity which is available in the outskirts of the galaxy to create enough attraction for these fast moving stars to exist, because of this very heavy objects being present in the exterior of the galaxy. And some of these objects are huge in numbers. So the theory is that 1 in every 3 stars is either a black hole or a white dwarf or a neutron star. So there are so many. If there are at least 400 billion stars in our universe, there, as per the estimate, at least 150 billion would be these black holes and neutron stars or white dwarfs. So that will probably explain the dark matter, and I think this is the latest understanding of what might be going on, because we do not see any proof of dark matter. Whatever studies we do, we cannot see dark matter. The properties of dark matter are defined in such a way that it's very hard to believe that such a matter can exist. So maybe dark matter is not real. Maybe it is the black holes or the neutron stars which have been created over so many billions of years, have accumulated outside the galaxy or moving out of the galaxy, creating that extra gravity for the stars to exist. And also by this process, when this extra mass is going out of the galaxy, this is how the galaxy evaporates. It is losing mass in this process. So I think these are certain things which are in a very early stage of our understanding, but I think this is important to understand how large galaxy function, the large places like galaxies, and what are the impact of different bodies in the galaxy that it creates on the surrounding stars, and probably affect our lives also. Whether the life can exist, where it can exist, all of these answers need to be answered. So I think the more study is being done, and as and when more findings will be brought out by scientists, I will bring them to you by method of coming live in front of you. This is a daily live stream. So if you have any thoughts, any comments, feel free to connect with us. And if you are able to join live, you are most welcome. Otherwise, you have a nice day. I take your leave for today, only to catch you again tomorrow. So bye bye for today.